Hi everyone. So this is a question from I.E.IRODOV, Problems in General Physics. A spool with a thread wound on it is placed on an inclined smooth plane at an angle of 30 degrees to the horizontal. The free end of the thread is attached to the wall as shown in the figure. The mass of the spool, if the mass of the spool is, it's not actually if it is m is equals to 200 grams. Its moment of inertia related to its own axis I equals to 0.45 grams meter square. The radius of the wounded thread layer is 3 centimeters. I want to find the acceleration of the spool axis. So this is the spool. This is the spool, and this is actually a disc. And there's a part here. This part, right? This part, along this part there is a thread that is being wound and it is tied to a wall. Okay, and the entire system is placed on an inclined wall, hence the spool is rolling down, as you can imagine. I think this is where it is uh, wounded, and it is moving like this with some acceleration a. The question is how to find the value of that acceleration. They're asking the linear acceleration value. Okay. So if I draw the free body diagram of the system, what happens is that like this is related to rotational motion. Hence you have to include rotational motion concepts to solve this question, right? So by using some free body diagrams, I can say that if this is that spool, then this is the point I'm considered to be point mass, and G force will be acting downwards. One second. Sorry. So mg force will be acting downwards. So, and since it is inclined with an angle of inclination 30 degree, there will be the weight force acting in this direction, that is mg sine 30, that is mg sine 30 degree, that is mg sine 30 degree will be 1 by 2, so therefore mg by 2. This is the value of the acceleration, sorry, the force being applied to that spool in this angle. Now, and there will be also other component we can derive, but it's not required. Now, I took these, I like resolved this, right? I resolved the weight force into mg by 2, and also mg cos 30 degree. That is mg root 3 by 2. Root 3 by 2 mg, because it's cos 30 degree, and cos 30 degree is root 3 by 2, root 3 by 2 mg. Now, along with this, a tension force will be acting due to the thread, right? If this is the axis. One second. See, if this is the actual axis, then tension force will be acting in this direction opposite to mg by 2, and hence entirely there will be an acceleration a. There will be net force Fn, that is ma, right? So now I will do some calculation here. So we can say that the net force is equals to mg by 2 minus t, right? Since let's assume that it is going downwards, it is mg by 2 minus t, where t is the tension force. Now F is also equals to ma, right? That is the actual value which you are solving this. So ma. So since I know the value of m, I can get the value of a here too. So it's mg by 2 minus t. Now let this be an equation 1. Let this be in equation 1. Now, using some rotational motion concept, I can say that the torque that is being generated here due to the thread from the center of mass here, from the center of mass, or from the center point of this spool, will be equals to I alpha, right? So we can know that tau, that is the torque, is equals to I alpha. That is also equals to force into perpendicular distance, Fr, where R is also the radius of this smaller disk, and that value is given to be 3 centimeters, right? So it is in centimeters, we have to properly convert into meters. Now we got I alpha equals to FR. We also know alpha equals to A by R. So I will substitute. So I times A by R is equals to FR. Therefore, I can say A is equals to FR square by A equals to FR square by sorry, I did a mistake. Okay, we don't want this actually. Now this F force is equals to tension, right? So it's actually tension force. So T times of R, this F is equals to T. So now if I calculate this, I will get tension is equals to I times of acceleration by R square. They gave the value of I also, we can just substitute in that. Now this is, let us consider this to be equation 2. So we got two equations. Now what I'm going to do is that I'm going to substitute the value of t of in equation 1 with the, from the equation 2. So I'll use this pen. Now MA equals to mg by 2 minus I times a upon r square. Now this goes there, so it becomes plus. So MA plus I a upon r square is equals to mg by 2. I may get the value of a common. If I get the value of a common, I can say a times of m plus I by r square equals to mg by 2. And finally, a equals to mg by 2 times m plus I by r square. Now I know all the values to be, hence I can simply substitute, I can get the answer. Hence, I got this, very important. Now A equals to mass. Mass they given it to be 200 grams, so you have to convert it into kg. So 200 by 5. 200 by 5 is 1 by, sorry, 200 by 1000, that is 1 by 5 kgs. And acceleration, that is 10 meters per second square, by 2 times 1 plus I, the moment of inertia, they gave it to be 0.45 grams meter square. So since it is in grams, I have to convert it into kg to be in SI units. So hence I can also be equals to 0.45 times 10 to the power minus 3 kilograms meter square. Hence I can also say it to be, if I simplify it further using exponentiations, I can say I is equals to 45 times that I'm taking there. So it is 10 to the power minus 5. Now I'm just substituting this value. We substitute this value in this here, this equation, in this expression. I get a equals to 1 by 5 by into 10 by 2. 1 plus I value is 45 into 10 to the power minus 5 upon radius. Radius now they gave it to be 3 centimeters. We know that 3 centimeters is equals to 3 times 10 to the power minus 2 meters. So I'm just substituting this too. Since 3 centimeters equals to 3 into 10 to the power minus 2 meters. So r square is 3 into 10 to the power minus 2 the whole square. So it becomes 9 into 10 to the power minus 4. So it becomes 9 times 10 to the power minus 4. This is 9. So now if I solve it further, I will get a is equals to, now this cancel with this to be 2, and hence this 2 and this 2 cancels, so it is 1 upon 1 plus 45 10 to the power minus 5. This 10 to the power minus 4 will go up, and it will add up with this, and it will become 45 into 10 to the power minus 1, that is 4.5. So 4.5 divided by 9 is 4.5 divided by, actually this is not 1, this is equals to, this is not 1, I read a mistake, this is actually m, right? So m is equals to, it's not 1, it is equals to 1 by 5. Okay, so 1 by 5, so it is 1 by 5. 1 by 5 can be written as 0.2. Okay, 1 by 5 can be written as 0.2. So this is equals to 0.2 plus this will become 5. So 5 and this becomes 0.5, right? So finally it becomes 1 upon 0.5, 2 plus 0.5, 0.7. So A equals to 10 by 7. I'm multiplying numerator and denominator by 10, so I'm getting 10 by 7 meters per second square. This is the answer. Now if I divide this, I will get the answer to be A equals to 1.4 meters per second square. This is the acceleration of the spool. Thank you.